The real number system, this is something that we learned at the beginning of the school year, but here is a quick refresher just in case we forgot what some of these terms are. So the real number system, the first thing that we're going to be doing is we have to simplify all of the numbers. Every time that we see something, whether it be in a square root or a cube root, whether it's in a fraction, whether it's a mathematical expression. So even if we had 4 plus 3, we need to simplify that first before we can decide what the classification of that number really truly is. So right here we have 10 over 2. Well, when we simplify 10 divided by 2, that's going to be 5. So 5 is the number that we're actually going to be classifying. The square root of 16. Well, we know the square root of 16 is 4, and that's going to be the number that we'll be classifying. Natural numbers. So this is the first one, the easiest one. This is something that you started working with when you were in preschool, even before that. So the natural numbers are the numbers that we count with. So let's think that we start counting if you were counting how many cookies were left in a jar. You would go 1, 2, 3, 4. Okay, those are our natural numbers. We naturally count with those. Our next number is going to be our whole numbers. Now, they're the same thing as natural numbers, except that it includes the number 0. So we just remember the whole numbers include the number 0. I always remember that because there's an O in whole, and it looks like a 0. So those are our whole numbers. Our next numbers are integers. So numbers that we can count with, the number 0, and now we're going to add in those negative numbers as well. So we've got -4, -3, -2, -1. That is the difference between our whole numbers and just our integers, is that we have those negative numbers in there. We still are including 0 and our natural numbers, 1, 2, 3, and 4. So don't forget those are integers as well. Rational numbers. Now, these are all the numbers that we've already talked about. So the numbers that we can count with, they're the number 0, they're the negative numbers. And the things that we're adding now is that they're the numbers that have a terminating decimal, which remember terminating means that it ends, and also numbers that have a repeating decimal that never ever end. So here's some examples. -8, that's a rational number. We also know that that's an integer. 1.75. All right, well, that's a rational number because the decimal stops, it terminates. 3 divided by 4. Well, when we simplify that, we're going to get 0.75. Well, that decimal stops as well, so it's a terminating decimal. That means that's a rational number. 125. Well, that's a number that we count with, so that's a natural number, it's a whole number, it's an integer, and it's rational. 2.66666 repeating. That's what those little dots mean at the end. It means that it repeats on and on forever. Well, this decimal does not stop. It's not terminating, but since it repeats forever, that means that we're still dealing with a rational number. And 1/3, which is actually the fraction 1 over 3. We use that as a division sign as well. So 1 divided by 3. You stick that into your calculator, you're going to get 0.333 repeating. Again, that decimal never ever stops, so it's not terminating, but since it repeats, it's still a rational number. The last set of numbers that we're going to talk about are irrational numbers. Now, these are the numbers that they just have a party. They have no rhyme or reason to them. They never ever end, and they never ever repeat. So pi, we use 3.14 to approximate pi, but if you actually get the digits of pi, it's a never-ending, never terminating, never repeating decimal number. So that is actually an irrational number. The square root of 5, if you put that into your calculator, you're going to find out that it stops at some point, but there's no in your calculator, but it actually doesn't stop in real life. So just because your calculator gives it 5 or 6 digits after the decimal point does not mean that it's terminating. The square root of 5 never terminates and it doesn't repeat, so that is an irrational number. Then another example here is a number 7.4953218 dot dot dot. Those dots mean that it keeps going on, that it didn't stop right there after the 8. So that pattern does not repeat and it does not terminate. It doesn't stop. So that means that that is an irrational number as well. Now you guys have seen this before. This is just a graphic organizer to kind of give us an idea of what in the world are we talking about here. So all of the numbers that we're discussing are real numbers. Even if they're rational or irrational, they're all still real numbers. Now, a natural number. That's a number that we count with. My favorite natural number is 5. I'm not sure why, but it is. So I would put a 5 in the natural number spot right here. Well, since it's inside this box, that means that it's inside this box as well. So the number 5 is a natural number. It's a whole number. It's an integer, a rational number, and a real number. All right? So wherever you start putting it, whatever else that box is inside, think of it as kind of maybe a box that you would get in the mail. If it's inside one box and you have to unwrap it to get into another one and another one and another one, then that means that it's part of that classification as well. So let's kind of look at this as some real life examples and see what we're going to be asking you to do. All right. So the number 17. That's the one that we're going to be classifying first. Well, we don't have to do anything to it. There's no radical sign. There's no expression there. There's no fraction for us to divide. So we can just start with 17. Now, we know that 17 is a real number. So I'm going to go ahead and I'm just going to mark it off that, yep, that's a real number. 17, is it rational? Well, let's think about it. Does it ever end? Does it stop after a decimal? It does. So that means that yes, it's a rational number. All right, now what do I get when I start thinking about 17? Can I count to 17? Yep, I can. I can start with 1 and go 1, 2, 3, 4, 5, 6, get all the way up to 17. So that means that it's a natural number. It's also a whole number, and that also means that it's an integer. So all 5 of these boxes need to be checked. So let's look at the next one. It's the square root of 4. We need to simplify that. Can you find the square root of 4? You can. It's 2. So what do we do with 2? Well, first of all, we know it's a real number because all of these are real numbers. But 2, can we count? When we're counting things, do we get to 2? Yep, I do. So it's a natural number. And since it's a natural number, that also means that it goes with all these other boxes too. That means that it's a whole number, it's an integer, and it's a rational number as well. All right, let's look at pi. We've talked about that in the past, but here is the example of what we would do for it. Pi, well, it is a real number, so we'll mark that box for sure. Now, is it a number that we count with? No, we don't count pi, so we're not going to mark anything in natural. What about, is it a whole number? Well, no, we know it's not a whole number because we have a decimal there. Let's see, so is it an integer? Nope, it's not an integer because it's a decimal. So now we're stuck with a rational or irrational. Well, a rational one means that the decimal stops, it terminates, or it repeats forever. Does pi stop its decimal points? Does it repeat? Nope, it doesn't. So that means that this is an irrational number, and that's all we need to put there. Negative 4.3. All right, we know that it's a real number. We're talking about real numbers. Okay, is it natural? Do we count negative 4.3? No, it's not, so we're not going to put anything in there. What about whole? Is it a whole number? Nope, it has a decimal point. Is it an integer? Nope, it still has that decimal point. All right, so now again, we have to decide, is it rational or is it irrational? All right, so let's look at that decimal. Does it stop? Does it terminate? It does. So even though it's negative, it's still a rational number. All right, down here, now we have an expression. 7.2 plus 1.8. All right, well, first we need to simplify that. So let's pull out our calculator. 7.2 plus 1.8. That gives us the number 9. So 9 is really the number that we're going to be classifying here. Well, first thing first, yep, it's a real number. 9. Okay, so let's look over down here again. Do we count to the number 9? We do. So that means that it's natural. And that also means that it's all of these boxes leading up to the real number. All right, our last box here, 2 over 3, or 2/3. Well, we need to put that into our calculator because we need to simplify. So 2 divided by 3. That's going to give us 0.666666 repeating. Now it stops right here in my calculator, but I can tell by this pattern that it doesn't really stop. It's a non-terminating decimal, but there is a pattern there, so let's see what we know. All right, it is a real number. We know that it's a real number because all of these numbers are real that we are discussing. Let's see if I can get it to check. All right, so do we naturally count with that number? No, we don't, so we're not going to put an X there. Is it a whole number? Nope, there's a decimal there, which also means that it's not an integer. Now, so we're stuck again with rational or irrational. Well, let's look at that decimal. It never ends. It does not terminate, but there is a pattern where it repeats. So that means there's a little bit of rhyme and reason to it. So we're going to call that a rational number. Classifying numbers is not very difficult. The one thing that you need to do is ask yourself questions the entire way. Remember, we need to simplify this. Whatever the expression is or the number is, if there's a radical or there's a fraction, that is our step one. Then you need to start asking yourself some questions. Do I count with this number? Is this number include 0 and then the numbers that I count with? Is it an integer? Is it a whole number, but instead it has the negative numbers? Is it rational? Does it have a decimal, but that decimal stops or it repeats? If you answer no to all those, then you know that it's irrational, but there's not a lot of rhyme and reason there. Remember, all of the numbers that we're talking about right now are real, so you need to make sure that you mark that as well. If you have any questions, feel free to email me or send me a message on Remind, and I will get back with you. I think you guys are going to do great. Have a good day.